Lesson 51, properties of isosceles and equilateral triangles.
Are we gonna have homework on Thursday?
Okay, so first of all, with isosceles triangles, the two sides that are congruent are called the legs. The third side is called the base, and the two angles at the base are called base angles, and the very top vertex is called the vertex angle. So the vertex angle is the angle formed by the two legs of an isosceles triangle. There is what's called an isosceles triangle theorem. If a triangle is isosceles, then the base angles are congruent. Then there's a corollary to that theorem that states if a triangle is equilateral, then it is equiangular. It's a corollary because if it's equilateral, then it's still isosceles, but since every side is congruent, all the angles will be considered base angles. So they'll all be the same. So we are going to prove the isosceles triangle theorem in our notes. So we're going to draw a picture for our given. And we want to prove that angle PQR is congruent to angle RST. Okay, so we are going to do statements and reasons for this. So number one, we know that the measure of angle PRQ is equal to the measure of angle TRS. And that's the vertical angles, or vertical angle theorem. Hey. I think that states that they're congruent, not equal.
Can you zoom in a little bit?
Yes. Second step, measure angle PRQ and PQR are equal. And measure angle TSR is equal to measure angle TRS. And those are by the hinge theorem. So measure angle PRQ equals measure angle TSR by the transitive property. So since PRQ is equal to TRS and TRS is equal to TSR, then they're equal to each other. And last, they will be congruent by definition of congruent.
Move it up one.
Move it up like that. Okay, we have another theorem that we're going to go over. Should I get a drink? Except before we do that, I just want to say the converse of the isosceles triangle theorem is also true. So if we just put converse of the isosceles triangle theorem actually and its corollary. Corollary are also true. So if you remember, converse is where you say if the conclusion, then the hypothesis. So if the base angles of a triangle are congruent, then the triangles are isosceles. And if a triangle is equiangular, then it is equilateral. Okay, I'm turning the page. We can come back to it after. The next theorem is, well, I think it has a name. It doesn't have a name. If a line bisects the vertex of an isosceles triangle, then it is the perpendicular bisector of the base. And then the converse is also true. So this is how it looks in a picture. So when you have an isosceles triangle, if you bisect the vertex, so that means that the two angles are congruent. That's the definition of bisect. These will both be congruent to each other. And since this side is congruent to itself, by angle side angle, these measures are, or these sides are congruent. And then by that theorem here, this is a right angle. So it's true for any isosceles triangle. Okay, that's it. End of note.